Bubbly, bubbly. Bubbly, bubbly. Set it! You see that girl with the big tic tac, she fi gimme the gimme.
Hi everyone! So basically, we are here to demonstrate to you the concept of an area. Expected that at the very end, the students would be able to first define an area and then second, explore the concept of an area. And now, let us tackle first the definition of an area. So an area is a count of how many unit squares fit inside a figure. Now, to fully understand the classic definition of an area, we need to picture out a unit square. And so now, going down deeper, we will give you some examples with the use of figures. Now, just like this, a unit square is a square that is 1 unit long and 1 unit wide.
Example number 1 is rectangle. First, we define what is rectangle. Rectangle is an equiangular quadrilateral. Opposite sides are congruent and parallel. All internal angles are right angles, since it measures 90 degrees. And now, let's look at a rectangle that is 12 inches length and 6 inches width. So now, let's find out how many unit squares of 1 inch by 1 inch squares are there inside the rectangle. Let's add all the squares inside the rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's equal to 12. As follows would be equal to 12 also. To sum it up, 2 plus 2 is equal to 4 plus 2, 6 plus 2, 8 plus 2, 10 plus 2, 12. Carry 1. 1, 2, 3, 4, 5, 6, 7. Therefore, there are 72 squares of 1 by 1 inch inside a rectangle. Hence, the formula area of rectangle is area is equal to length times width, if our answer is the same. So let's substitute the length. Be 12 inches. The width would be 6 inches. So let's multiply the length and the width. 12 times 6 is equal to 72 inches squared. So now, we came up with the same answer.
Second is a parallelogram. A parallelogram is a quadrilateral, four-sided figure that has opposite sides that are parallel. We need to know the two distances of a parallelogram. It has a height and the length of the side that is perpendicular to the height called the base of the parallelogram. So this is what we call the height of the parallelogram and the base. A parallelogram has similarities in a rectangle. If we start with a typical parallelogram, we can make a few alterations in order to know the formula area of a parallelogram. First, let's cut along its height. Now, let's remove the triangle. Then move it to the opposite side. So, it fit perfectly rectangle. Since we already know the formula area of a rectangle, which is length times width, we can now apply it to the newly altered parallelogram. The base of the original parallelogram is now the length of the rectangle. And now, the height of the parallelogram is now the width of the rectangle. Using the terms base times height instead of length times width, now we can now see that the formula area of a parallelogram is base times height.
So we hope that you have learned something about this short presentation. Thank you for watching. Bye!